Look at this. Let me change my colors here. And make that a little bit thicker. And let's go to, I don't know, what do we go to? Let's go to this darker purple. Be nice. All right, and we want to do an inverse graph, right? So do you want to do one with a negative? You know what? Let's just do a regular one. Y equals 1 over x. Okay, what does that look like? Well, it's an inverse. So that means, now you could put the little XY chart if you wanted to, but just understand what it means to do an inverse. If I put in a value for x, what's the y going to be? It's just going to be 1 over whatever I'm putting in for the x. So let's think about this. What if I put a 0 in there? What's 1 over 0? It's nothing, right? It's not 0, it's what? It's undefined. So that means this line right here, this vertical line right here, anytime I put a 0 in for x, I can't get any number for y, can I? So this is kind of like my dotted line right here. Okay, we don't really need to show that, but that's my asymptote. Remember that weird word? That means my graph cannot cross that line. It cannot go across it at all. It's kind of like a force field, right, that it can't go across. Electric fence or whatever you want to think of it. What if you stick a 1 in there? Okay, so what if you stick a 1 in for x? What's 1 over 1? So if I put a 1 in for x right here, so if x is 1, what's y going to equal? It's going to equal 1. What if I put a 2 in for x? Remember, this is an inverse function, isn't it? What if I put a 2 in for x? What's it going to do? It's going to be the inverse of it, right? So if I put a 2 in for x, what's my y going to be? It's going to be the inverse of 2, which is 1 over 2. What if I put a 3 in for x? What's my y going to be? It's going to be the inverse of 3. What's the inverse of 3? It's 1 over 3, which is a third, which will be a little bit lower. The more I go over, the closer and closer it gets to that x-axis, doesn't it? But it will never touch. I could go to 1,000,000 on the x-axis. What's y going to be? It's going to be 1 over 1,000,000, which is super, super, super close to the axis, but it still will never, ever touch. But that's all I need right there. Well, is that all it's going to be from here to here like this? No, because I can do some numbers in between 0 and 1. Give me a number that's between 0 and 1. What about a half? So if I put a half in for x, what's the y going to be? It's going to be the inverse. What's the inverse of a half? It's going to be 2, isn't it? So if I go over a half, I go up 2. See what I mean by it's an inverse function? Whatever you put in for x, the y is going to be the inverse or the reciprocal of it. What if I put in a 1/3 in for x? I just go over a third. How far up am I going to go? I'm going to go up to 3. About like that. See what your graph looks like? And now it's going to look like this. If I could connect them. Yeah, almost made it through. Let's see. I went up a little bit. That was terrible. Let's try that one more time. It's a little easier on paper with pencil than it is this machine. Yeah, it's terrible. Okay, come on. I got to get a running start. Okay, good enough. All right. So it kind of looks like that. All right. Is that all there is to it, though? No, because what numbers did I not put in for x? Nobody wants to talk to me today? What numbers did I leave out? I put in a 0 and everything positive, right? What did I leave out? I didn't put any negative numbers in, did I? So let's put some negative numbers in. Well, we talked about 1,000,000, though. I didn't put it in there. All right, what about negative numbers? Well, let's put a negative number in there. Let's put a -1 in for x. If I put a -1 in for x right there, what's my y going to be? It's going to be -1 right there. What if I put a -2 in for x? What's my y going to be? It's going to be the inverse of -2, which is -1/2. What if I put a -1/2 in for x? What's my y going to be? It's going to be the inverse of -1/2, which is -2. That's really all the points you need right there. I don't even need to put the 3 or the 1/3 in there. That gives me an idea what this thing's going to look like, isn't it? So watch. Let me kind of go away. Oops. That was pretty close. Yeah, it did touch. I'm trying to make it so it doesn't touch. Right there. My error is pretty bad. Let's try that again. There we go. So it looks like that on that side. And let me start up here like this. Might be a little easier. Going left to right. And that's not bad. All right. I'm not going to be really, really picky as far as that. But I do want to see this. What am I going to be picky about? I'm going to be picky about this point right there and this point right there. That's going to be very important. And I'm also going to be picky about this asymptote right there. So I'm looking to see that it's not going to touch this line right here. And of course it doesn't touch this line as well. Now that's your just basic average ordinary inverse function. What if we change it up a little bit? What could we write it as? Y over x, I don't know, what can we put in there? Like plus 2? What if I did that? What would that do to this purple graph right here? To the left. Yeah, it moves everything to the left. Okay, because remember, if you change your x value, if you change the function itself, it moves it left or right. And it moves it in the opposite direction than what you think it will. Okay, you see the plus and you're all automatically thinking it moves it positive. But when it changes the x value, when this number is with the x, it moves it in the opposite direction. We've talked about that. In fact, next period, the 9th graders come in and Mr. Smith comes and teaches that class. Those 9th graders right now are actually learning how to do this stuff, and they're shifting things left and right, up and down. They're doing it with straight lines, not with these. Actually, no, they did it with parabolas. They were doing parabolas the other day, and I was kind of surprised for Algebra 1 to be doing that. But so
loosely did that in algebra, but not necessarily understood it.
Right, yeah. And I'm sure that most of the kids in that class right there are probably not understanding everything about it. But it just goes to show that even 9th graders are learning how to do this. They're not doing an inverse function, but they're doing parabolas. I don't think they're doing any others. I think they're just doing straight lines and parabolas. But anyway, what do we do with this? We move everything to the left 2 places. So I'm thinking of this point right here as kind of like my origin, right, to this graph, because everything comes from there. So what I'm going to do is I'm going to move this to the left 2 places, 1, 2. Now, this is my asymptote this time, not the y-axis. This is right here. So watch what I'm going to do. I'm going to put a dotted line, and this is the line that my new graph cannot touch. Okay? So this is the asymptote for that. So picture this red one. Okay, I'll do this in red. Picture this red one looking like the purple one, except I just shifted everything over to the left 2 places. Everybody see that? So this is kind of like my origin with this one. So what did I do over here with this purple one? I went 1, 1, didn't I? So what am I going to do over here? I'm going to go to the right 1 and up 1 right there. And I'm going to go to the left 1 and down 1 right there. See that? And then what am I going to do? I'm going to go over 2 and up a half. I'm going to go over half and up 2. Right? So once you realize what these things look like, it's not that hard to do. So watch, this goes like this. Yeah. It's not as easy as it looks. Okay, so looks like this, and then this looks like that, and looks like that. Okay, pretty close. Looks like that red one right there. So what was the only difference? The only difference was I took that purple one and I moved everything. I picked it up and I moved it to the left 2 places. Even took that y-axis, which was your asymptote, and I moved that 2 places to the left. So remember, this can get really, really close to this dotted line, but can never touch it. Why can it never touch -2? Because if I put a -2 in for x, what's -2 plus 2? It's 0. So that means if I put a -2 in for x, I can't get any value whatsoever for y. Doesn't exist. That's why I put the dotted line right there. So that's probably the hardest one out of all the graphing that you're going to have to do. Does that make any sense? All right. I mean, let's do this. Let's start from scratch, and let's just do one. Oops. I thought I. There we go. Let's get rid of all that. Let's get rid of all this mess. Okay, what if I did this? Let's just go with a dark blue. What if I said y equals 1 over x minus 3 plus 2? What if I did that? What would it do? Well, what does this thing do right there? It moves it where? To the right 3 places. What does this thing do? Moves it up 2. So my origin was here, isn't it? Where's it going to be? It's going to be at 3, 2. You see that? So now watch this. I'm going to do a new x and y axis in a different color. Actually, the blue's going to look too much like the, I'll go this purple. The blue's going to look too much like that black, I think, on the screen. So watch. That's going to be one asymptote. Let's make it a little thicker. And then this is going to be another asymptote. And so what we're going to do, see that? It's kind of like you got a new x and y axis, but it's not here at 0, 0. Where's the beginning of it? It's at 3, 2. And then so what do we do now? Let's go green. So I put a, see, 1 over 1 up 1, 1 over 2 up a half, over half up 2. See that? And that's enough points to get you started. Looks like that. Oops, a little squiggly, but you get the idea. And then what's this going to do? It's going to go to the left 1 and down 1. And you get the idea for that too, don't you? Go 2, down a half, go over a half, down 2, and it looks like this. Alright? And that's what you would do for something that looks like that. You could make these dotted lines. I made them purple. I just made them solid just to make them a little bit cleaner. But you can make them dotted lines if you wanted to. Now remember, this is never going to hit this line right here. It's not really the x-axis. It's y equals 2. It's the line y equals 2, and this line is x equals 3. It's not going to hit any of those, and that's what it would look like. All right, enough of that. What else did we have? Questions on the tests. Let's see, let's go back. Where was I? Okay, there we go. There we go. All right, so that was basically an inverse function. That was number 4, wasn't it? And then we had number 1 and number 8. Let's do number 1. I'll tell you what, I'll just do this on this background. This time they give you a graph, and you have to figure out what the equation of the graph is. So you got to look at the shape. The shape is very important. This looks like it hits. Looks like it hits right here. Just looking at the quiz. All right, and then it looks like it hits here, and it looks like it hits here. So this is the basic shape of it. Kind of curves up like that, and it kind of curves up like that. All right, should be a little bit smoother here, but you get the idea. All right, on the test it looks a lot nicer than that. But what's the shape of this? It's a parabola. So what equation has the shape of a parabola? Y equals what? X squared, right? So that's the shape of a parabola. You know it's going to be x squared. But the problem with this, it's not just the vertex of this parabola is not right at our origin, is it? So if it was right there at the origin, then you would just write it like this. Okay, but that's your basic form of it. But what did we do to our vertex? We moved it, didn't we? We moved it. Let's go left. Let's go x first and then y. Which direction did we move it? 1, 2, 3 to the left. So what do we do to this if we move it 3 to the left? We move it plus, right, because we went to the left and that actually goes plus. So it's x plus 3. See what I did? I just changed the x, didn't I? Kept it inside my function. Then what did we do to it? We moved it down 1. Right? So if I move it down 1, the up and down does go the direction where you think it's going to go, right? If it moves it up, it's plus. If it goes down, it's minus. So this is minus 1, and that's your equation right there. That's the equation of that parabola. It's that simple. Just look at the shape, realize what kind of graph it is, and then figure out, did I move it left or right, and how many places, and move it up and down. And make sure you put it in the right spot. If I move it left or right, that goes with this right here. Make sense? Okay. What is, what if I had a shape that looked like that? What is that equation right there? That's a square root, right? That's y equals the square root. Okay, what if I had an equation that looks like this? One swooshes up like that, and then it goes down like that. What is that equation? That's a cube function, right? So it's y equals x cubed. And then the v, I'm not going to draw the v, but what's the v? Absolute value. And if it was just a straight line, it's linear, it's y equals mx plus b, right? Okay? Make sense? All right. Good. That was number 1. What about number 8? Let's do that one. This is our composition stuff. Hopefully you're finding this not too bad. I think we've covered it pretty well, don't you? Squared plus 18x minus 3. Alright, and the question says find f times g of 2. Alright, if it says 2 and it doesn't just say x, now if this just said x right there, what would we do with these two functions? Just multiply them together, that's right. Okay, so you do a little distributive property, right? A binomial times a trinomial. You could do that, but they stick a number in here. They don't just put an x on this one. They put f times g of 2. So that means you put a 2 into both of the functions, and then what do you do once you get both of those answers? Multiply them together. That's all there is to it. Okay, so that's what we're going to do. We're just going to do a little substitution. So put a 2 in for this. So it's going to be 2 plus 1, which is what? 3. So f of x is 3. Now put a 2 in for the g function. Put a 2 in for this. So it's negative 3 times 2 squared plus 18 times 2 minus 3. What's that? That's 4. That's negative 12. That's plus, oops, what did I do? 36 minus 3. What's that?
21.
That's negative 15, and that would be 21, right? Is that right? It's 21? Yeah. All right, so that's putting the 2 into the g function, and I get a 21. So now what do I do with those two numbers? This says right here that I multiply them together, doesn't it? Now I could say, what else? What are some other options? I could have said what? I said f times g here. What else could I have said? Plus, right? I could have said f plus g or f minus g or f divided by g, correct? All right, I could have said any of those things, but on this particular problem it said f times g, and then you just multiply them together, and that's your answer, just like that. Make sense? Now you could have done it this way if you wanted to. You could have taken this and multiplied it by this, do distributive property, and then plug it in. But I wouldn't do that, would you? I think it's a lot easier just plugging the number in first and then multiplying the two things together. I would definitely do it that way if I were you. If I was me, I would do it that way. All right. Okay? What about the f composition g of x? Let's do one of those. I know you're not asking about it, but I just have a feeling we need to go over one. Is that all right? And if you know how to do them, that's great. If not, maybe it'll help. And maybe everyone in here knows how to do it, but I just would feel more comfortable going over one. Okay. Now on these, I could ask you one or the other, couldn't I? I could say f composition g of x, or I could say g composition f of x. Doesn't really matter. Let's just do f composition g of x. All right, so that's what they're asking you to do. They're asking you to find this thing right here. Put the word find in front of it. So we're finding this. What does that mean? It means f of g of x. You're probably saying, well, what in the world does that mean? Okay, that doesn't help me any more than that. Well, I don't know. Maybe it does. I hope it does. So what are we doing? We're taking the g of x and we're putting it into the f function. We're going f of this, right? So we're putting this number into the f function right there. So that means we come up here, we're putting this into the f function. We're putting this into wherever your x is on the f function. We're taking that whole entire value and putting it in right there. So what does that mean? It means 3 times whatever you're putting into it, right? So 3 times 3x minus 1. Then you got to finish it off. You got to stick that plus 12 right there. That's your f function, but instead of this being x, you stuck in the g function in its place. You just a little substitution. And now you just work this out. Make sure you distribute. That's 9x minus 3 plus 12, and that's 9x plus 12 or plus 9, and that would be your answer right there. Easy as that. Make sense? Okay. I think if you messed up on the quiz or something, my guess is you probably just did some bad arithmetic or something like that, okay? But hopefully you understand the whole process. Whether or not your arithmetic is right, that's going to be up to you, and that's, you got to be careful, and you got to really have clear thought and everything else. Everybody feel good for this? All right, hope so. I think we've taken a lot of time to go over this stuff. So, test tomorrow. And it's going to be, again, sections 3.5 to 3.7. We good?